Hi everyone, this is the very unhappy birds sack that I'm going to go through in terms of the worked solutions. So the pigs have been stealing the birds' eggs, they make them unhappy, very unhappy. To recapture their eggs, they catapult themselves through the air to hit the naughty pigs, but they need to follow the right path exactly. So I've got a highlighter at hand. That's the most important thing, I think, as we're going through these worded questions, because it's obviously very wordy and we want to try and pick out the key things in it. So the following image outlines the path that the very unhappy bird must follow in order to steal the bird's eggs from the pig. The very unhappy bird starts at 0, 0. The pig is at 10, 10, and the bird must pass through 5 and 4 on the grid in order to fly on the correct path. The path of the angry bird is modeled by the quadratic function of this form. Using this information in the diagram below, complete the following questions. So part A says find the value of A, B, and C, and hence write the equation of the flight of which the bird must follow to collect the eggs from the pig. So first thing I'm going to do is just label everything that I can see on the diagram just to make it very clear for myself. And next I'm going to have a think about, okay, well, I have an equation that I need to get to. And what is the information that I have? I have 3 points here. Now, it is true I do have 2 special points, which are the intercepts. So you can absolutely do it through intercept form. I might label that differently actually, because these are not the same B and C. So if you did it like this, that's fine, but you would then need to expand it to get it into this form here. So I'm just going to use the 3 coordinates that I have to be able to find these 3 unknowns. Now, just as a quick note, when I'm writing in the black pen, that's going to be what you would write on your sack. I'm going to also write in the red pen, which is going to be CAS instructions, because remember, you never ever write CAS instructions on your sack. This is just for you to know what we would do on the test. Okay, so from this point, what we want to do is essentially define our function. So we want to define f1 of x is equal to ax squared plus bx plus c. And then we want to go ahead and solve that as a system of equations. So that's just to give you a bit of a heads up. So let's move to our CAS calculator and substitute in all of our points. So when we're subbing in our points, for example, the first coordinate is 0. So we would say f1 of 0 is equal to 0. f1 of 5 is equal to 4. So that's how we write it. This is our x value and that is our y. Okay, onto the CAS. So we're going to go ahead and press menu. We're going to add calculator. The first thing, as I mentioned, is we're going to define. So we'll go to menu 1, 1, and I'm going to define it as f1 of x. So that's the first function of x. And I'm going to type in a times x squared plus b times x plus c. I want you to make clear note of the fact that I've pressed times. If you don't put a times there, it's not going to work. It's going to say false. Okay, now that I've defined it, I can then go ahead and solve it. So I'm going to go to algebra, solve. Oops, sorry, that's just to solve one equation. Menu, algebra, and we're going to solve system of equations. So that's 2 equations, and I'm looking for A, B, and C. Sorry, I should have typed in 3. Anyway, so now I'm going to type in f1, and notice that it goes bold because it's recognized as a function. And as we said before, we write in our x value is equal to our y value. f1 of x, which is 5, is equal to 4. And the last one, f1 of 10, is equal to 0. Now when we press enter, we get everything. Now, what you'll notice though is that this is in decimals, and what we want to do is we want to work in fractions. So generally in our math sacks, we work in exact values, and we definitely want to be working in fractions. So we're going to go to the home page if you have this issue. Click 5, which is setting, 2, which is document settings, and we want to ensure our calculation mode is on exact. So in general for methods, we always want to do exact. Now I'm just pressing the up button to get there, and I'm going to press enter to bring it down, and enter again to give me my values. So back to the sack itself, I end up getting A is equal to negative 45, negative 4 on 25. We don't need an X. B is equal to 8 on 5, and C is equal to 0. Now, if you wanted to include some sort of working out, you can absolutely do that. I'm just going to rub out all these calculator things since you just saw it. You can do, equation 1 is the first coordinate 0 equals A times 0 squared plus B times 0 plus C. That's fine as well to show you working out. But here I'm seeing 3 marks, which would probably be for each of these here. Okay, question 2 says, find the discriminant of the equation found in part A and hence show that there are two solutions. Now, I just want to talk about show that questions is there to get you to start somewhere else and prove that this is the situation. Okay, so it's not as clear as probably the next ones, but show is a very important type of question. So pay attention to that word. Okay, so it's giving me very clear instructions. Find the discriminant of the equation. I might actually just write out the equation first. And then remember the c is 0, and then find the discriminant. So we know the discriminant is b squared minus 4ac, and c is just 0. Now, as long as you've shown enough working out, you can put this into your calculator. You don't have to worry about doing it in your head. This is 0 times all of this, so that's kind of nice though. So this part you probably can just do on your own. That's 64 on 25. So because the discriminant is greater than 0, so we can say as the discriminant is greater than 0, there will be two solutions. Okay, next one. Everything that goes up must come down. Complete the square of the bird's flight path and hence show that the turning point is at 5, 4. So this is another example of that show that. It's wanting you to prove that the turning point is at 5, 4. It's not saying use it. It's saying start somewhere else and then prove to me that that turning point is 5, 4. So this is the answer that you should get. Don't touch it as part of the question. It's not information for you. It's an answer. All right, it specifically asked me to complete the square and it's also worth 4 marks. So clearly here, I really need to show my working out by hand. I can use the CAS to help me along, but I should be showing a lot of working out for this. So again, I'm just going to write down the equation and I'm going to start completing the square. The first thing when you complete the square is that you need to ensure that you factorize out. We don't want anything in front of the x squared. This is the tricky part, I suppose. How would you factorize this? So as just a little bit of a side note, of what you would do. If I had, for example, 2x plus 4 and I wanted to pull out a 2, what you'd notice is that that's, naturally x plus 2. But what is it that you've actually done? You've done 4 divided by the number that you've pulled out. So we always do our value divided by the number that we've pulled out. And this is where I'm trying to tell you that you should use your CAS calculator for this. So if you go 8 on 5 divided by negative 4 on 25, you actually get negative 10. So that's really nice there. Sorry, there should have been an x attached. Okay, now that we've done that, it's really easy to complete the square from there. So let me not skip steps. So what we do to complete the square is we add half of the middle term. So that's 5, and then we subtract that as well. I should have written it in different color because this is not CAS instructions. This is absolutely something that you need to be doing. Okay. Now, this factorizes down into a perfect square. So we end up with a double bracket, and it's going to be a minus because the 10 is a minus squared, and then there's a minus 25 left. And finally, what we're going to do is we're going to expand this into our bracket. So with the squared bracket, that's untouchable on the inside. We just factorize it expand it to the outside. And here, it's a fraction. Denominators, they match. So 25 divided by 25 cancels out. So you end up with negative 4 times negative 1, which is going to be positive 4. So that is the square completed. And so then it's saying, hence show that the turning point is at that. So the turning point we know is at h and k. So we can say, h equals 5, k equals 4. Therefore, turning point is at 5 and 4. So we've proven it through completing the square. Okay, part D says, what is the height of the very unhappy bird when the horizontal distance is 7 meters from the starting point? And it says, give your answer in exact form, which we'll talk about in a sec. So as I'm going through, again, I'm still highlighting. What is the height? Now, the height is my y value. That's what I'm looking for. When the horizontal distance is 7 meters from the starting point, it's really important that you know where it's referring to, because sometimes it asks from the end point. So that's a little bit confusing. So this is saying when x is 7. And it does just mention as well to give your answer in exact form. So this is what I was talking about. We want to make sure that it's in a fraction or a surd. It's not in decimal, because if it's in decimal, then we don't have the full answer. So this really indicates that we should be doing this on our calculator page and not our graph page, because on our graph page, we can't get exact form. So back to our CAS calculator, what I'm going to be doing in this case is just simply substituting in the value of 7 in order to be able to find y. Sorry, I did say back to our calculator, but I'm just going to go ahead and substitute it into the equation first so you can see what I'm going to type in. And it is also, again, good to put, especially 2 marks, there has to be some sort of working out. You can't just come up with an answer. So you can substitute it into this expanded form, or you're also welcome to substitute it into the turning point form. Either way, it's the same equation. Sorry, instead of x, we'll have 7. So I'll just check that that is indeed the right equation. Yep. And now onto our CADs. We can just go ahead and do it. So we're going to negate the answer. 4 on 25 times 7 squared. Whoops, that's a 6. Plus 8 on 5 times 7. Now we want to just make sure that when we've pressed enter, the fractions have worked out, because I was a little bit lazy and I didn't use brackets. Sometimes it might multiply by the denominator instead of the numerator. So if that happens, just make sure you might need to type it again using brackets or using the proper fraction, which is you do control and then the divided by sign. Okay, so here we got 84 on 25 meters. So that would be the exact height there. Okay, part E, what is the horizontal distance of the very unhappy bird when its height is 2.56 meters? Give your answer in exact form. All right, so now we're kind of doing the same, but the opposite. So now it's asking for what is the horizontal distance? So horizontal distance is x of the very unhappy bird when its height is 2.56 meters. So this time we know that y is equal to 2.56. So this is going to be a little bit different this time, and it's in exact form. So similarities, I'm going to do exactly what I did before. I'm going to substitute it into the correct place into our equation. I'm not sure why I did that. That's just x squared plus 8 on 5x. This time, so remember, red calculator instructions, we're going to solve for x. I don't know what x is and I need to look for it. And because it's in the equation, I need to solve it. And I need to write this comma x so that it knows what I'm doing. It knows what I'm solving for. So back to our calculator, menu 3.1. That's one of the most important things you need to know. Menu 3.1. And I'm going to go ahead and type this in. So 5, 6 equals negative 25. Ooh, I might just use fractions so I don't make a mistake. Negative 4 on 25 x squared plus 8 on 5 x, comma, x. All right, so it tells me that x is 2 or x is 8. All right, now I just want to point out one really quick thing. You could actually have defined your function using the x and the y, and then that way you can just substitute in numbers a lot quicker as well. So that's another option. So if you feel confident, feel free to define it and substitute using the define function. All right, that's it for question 1. Let's move on to question 2. So there's a lot of words here, a lot of words. We're going to go ahead and highlight as much as we can. Once the very unhappy bird has collected all of the eggs from the pig, he needs somewhere to store them. The very unhappy bird decides that he must construct a rectangular area that is fenced off so that the eggs are safe. The very unhappy bird only has 40 meters of wire to build his fence. He wants to make sure that he builds the largest area he can to give them the most space possible. The very unhappy bird decides that he will use an existing brick wall to form one of the lengths of this area. Okay, so after we've highlighted, or while you're highlighting, what I would do is annotate. So I would either draw things or I would write what information has this given me. So for example, rectangular area, I know it seems obvious, but I'm just going to draw a rectangle. This one's probably more important. 40 meters of wire tells me that the perimeter is equal to 40 because that's going to be the total amount that I can use. He wants to make sure that it's the largest area. We'll probably need that a little bit later. And the existing brick wall to form one of the lengths. So this is where the rectangle comes in place. And in fact, it's very much what part A is asking me, which is to draw a diagram in the space. Now I'm going to use this information. First of all, it's a rectangle. Secondly, we've used an existing brick wall. So I'm going to put dashes there to indicate that that is not part of the fence. So the rest is going to be the wire. So the perimeter not the full perimeter, but the perimeter of the parts that we're going to use, which is here. All right, now it very specifically asks me to say, let X represent the length of the area and W to represent the width. So the width is the shorter part, and oops, that's going to be X there. Okay, so that's the diagram drawn. The next part then says, show that the width of the rectangular area in terms of X is given by that. So again, it's a show that question, which means start somewhere else and prove that that is the area. So you have to show me how we get there. You can't use it in your question. Now, looking at what we have before, we know that the perimeter is equal to 40, and we know that our area or our perimeter of what we have is W plus X plus W. So that's 2W plus X. That's going to require the wire fencing, and that is all going to be 40. So that's my equation that involves W and X. So that's the first place to start from. Think of what's an equation that involves the two of them. And now I'm going to rearrange to get W by itself. So the first thing I'm going to do is I'm going to take the X to the other side, and then I'm going to divide by 2. Now, the one thing about this is it looks very similar, but is not exactly the same as this. If you'll notice, the negative has been factorized out. So that's what that looks like. All right, and it looks exactly the same as this. I've just taken the negative out. This was a positive, and when you factorize a negative, the sign changes. All right, next part, let A represent the area of the rectangular enclosure, show that the area is this. So again, it's a show that. Now, the reason we give show that is say you couldn't do this. Say you couldn't figure out how to do this. You can now use this in the next part. That's why we do it, to help you along the way in case you can't get that question. So if you couldn't get one part, don't give up. Please keep going and just use the answer that we've given you. Okay, so we're trying to find the area of the rectangular enclosure. At a brief glance, if I were to do the area, it's just length times width. So that's W times X. But of course, we don't ever express functions in terms of two variables. We can't express them in terms of W and X, and that's the whole purpose of this. Now I can substitute that directly into my W. Okay, and what we're going to do now, again, we have to make it look like this, is we're just going to expand. So I'm going to expand that in. So that'll be negative x squared minus 40x all on 2. And then I'm just going to rearrange to make it look a little bit better. So negative x squared on 2, I'm going to split up the fraction. Sorry, that was Siri going off for no reason, if you heard that. Here we go. There's a little bit of a trick here. We're expanding this x in, but we are also expanding the negative in. Okay, so it's a little bit confusing, so that should be a plus there. I thought there was something strange. And that's also what this show that is really good for. Like, compare your answer. That's plus, and I had a minus, so I did something wrong. Okay, from there, I'm just going to simplify, and I can also notice that the x term goes first. So 40 divided by 2 is just 20. So that'll be A equals 20x minus x squared on 2. And that's exactly what I have there. Okay, part D, complete the square to find the equation of the enclosed area in turning point form. So again, we are completing the square. It's worth 4 marks, so it's clear that I need to show all of my working out. So what I have is 20x minus x squared on 2. First of all, I definitely want the x squared term to be first. And again, we don't want anything in front of the x squared. So I need to factorize out negative a half. And if you remember what we did before, we would divide the term. Okay, so if I'm factorizing out negative a half from 20, we would do 20 divided by negative half, which would actually be minus 40. Like this. All right, from there, everything is going to be the same. Sorry, there should be an x. I keep forgetting to write that. Okay, so we're going to go plus 20 squared minus 20 squared. And then now this is going to factorize to a perfect square. So we're going to double bracket. And then 20 squared, we'll think of like 2 squared is 4. And then the 0 doubles. So that's going to be minus 400. And then now I'm going to expand the half in. So we're going to have negative a half x minus 20 squared plus, and then 400 times a half is going to be 200. All right, then it asks us to write down the coordinates of the turning point. So that's H and K. So that's going to be 20 and 200. And then we're going to sketch the graph of the rectangular enclosure on the axis below and label all axial intercepts and turning points. So in this case, we don't necessarily know what the x-intercepts are. And I think this is a good chance to just practice sketching on the CAS calculator. So we're going to turn to the CAS so that we can see how we might be able to sketch this in order to be able to get all the x-intercepts and the turning points and so on. Okay, so we're going to go to Home and we're going to go to the Graphs page and I'm going to press Tab and it'll take me to F2 because if I go to F1, it's the equation I had previously. Now, F2 is that area equation that they gave us, which is 20x minus x squared on 2. Now, again, just check that it's become a fraction. I just pressed Tab. Now, you can see that this looks like a line, really. What we need to do is fix up the zoom. So we can scroll over and we can keep making it bigger until it fits. So I'm just double clicking on this part here. So that's 100. Still not big, maybe 300. Yeah, that looks pretty good. Maybe a little bit too big. So 200. Oop, that's not 200. All right. Now, so what we can do is actually just hover over, and then yours should turn into a hand. If not, just hold down, and it'll turn into a hand that's able to move it. So just like this. So I've just done this just for ease for myself, just to be able to shuffle things around. You can see that the axes do change. So I'm just going to fix that up there. And I'm going to grab this axis and change that as well. So probably not that big. Maybe 40. Yeah, that was actually a pretty good guess. 50. All right, and I think that I should make this slightly bigger. Okay, here we go. We've got a quadratic and you can shuffle things around. You can move whatever you want. Now, the first thing we're going to do is we're going to find our x-intercepts. The first one's obvious. It's going through 0, 0. But to find the other x-intercept, we go to Analyze, 0. And what we do is we scroll to just before it, click, and then scroll to just after and click. So we have 40 and 0. For the turning point, it's a maximum. So we'll go to Analyze, Maximum, and then we'll go to just before the turning point till after the turning point. All right, so now we've got all of our key points and we can go ahead and draw this into our sketch. So this will be 0, 0 and 40, 0. Now this grid's interesting because you kind of want to make sure that you're exactly in the middle. That doesn't really look like it's in the middle. I don't know. I reckon let's just go there. That looks like close enough to the middle. All right, and then that can be 20 and 200. Okay, now what we're going to do is we're going to draw a parabola. It's a bit wonky. Try to draw it as good as you can. Now, one thing I noticed while marking the tests is a lot of people were doing these sketches thinking they're artists. That's not okay. All right, you need to draw one straight line. So I don't want to see any parabola like this. One straight curve. All right, you will lose marks for it. All right, so that's our parabola there, and we've got all the key information labeled. What's the maximum area? So this is where the maximum occurs, and this is that maximum area. So that's going to be 200 meters squared. All right, great. We're up to the last question now. So the location of the pig has changed. It's now harder for the very unhappy bird to find the correct path to the pig. The graph below shows the very unhappy bird's first attempt at trying to catch the pig and his second where he did manage to do that. So the first attempt looks like it's a line and the second attempt looks like it's a quadratic. So the first attempt of the very unhappy bird to reach the pig did not allow the bird to catch it. The direction represents a linear equation with coordinates 7 and 19 on 6 and has a y-intercept of a half. Find the equation. All right, so let's see what we know. Linear equation, so that's that part done. This is going to be a coordinate that we can use, so that's an x and a y value. And then we know that the y-intercept is a half, which is actually just your c value. So immediately I can just substitute that in like that. Now in order to find m, what I can do is substitute in x and y and solve. So y is 19 on 6 equals m times 7 plus a half. And into our calculator, we can write solve, comma, m. All right, so onto the CAS. All right, so that's m equals 8 on 21. So find the equation. That'll be 8 on 21, x plus c. Okay, part B. So the equation of the very unhappy bird's second attempt is modeled by this quadratic here. Write down the coordinates of the points of intersection between the first attempt and the second attempt. So what we're going to do whenever we have an intersection, it's when the two equations equal to each other. So the first equation was 8 on 21 x plus a half. Actually, we don't need this y equals part. Equals to this equation here. Now again, it's really important to check the marks. This one's only worth 2 marks. So that would be 1 mark to write that. And then the second one would be to then solve for x, like to actually give your answer. So again, I'm putting this straight onto my CAS calculator and I'm going to solve for x. All right, so onto the CAS. We're going to go to solve 8 on 21 plus a half equals. I probably should use the fractions just so that it doesn't make a mistake. So that's just me being a little bit lazy, but make sure you use your fractions. Oops, 4 on 5x. Okay, making sure I've typed everything in correctly. 8 on 21x. See, this is why it's really important to check. I forgot the x and that would have given me the wrong answer and I would have had no idea. Plus a half equals negative 25. Yep. That looks good. All right, enter. Now that looks pretty gross, but it doesn't say to whatever decimal place, right? It just says write down the coordinates. So that implies that it should be in exact values. Okay, so our x value is going to be, I'm just going to expand. So I'm looking at my CAS, but you can look at yours while you're doing this. I'm just expanding it straight in. So that would look like 5 times 22 is 110 on 42. And then, so that's our first one. So I can just do that because I'm going to need to find the y value in a moment. And our second point of intersection, again, expanding that in, is going to be plus 110 on 42. Now, I don't know if I've gone, no, all right, I think it looks pretty good. It just looks like a crazy answer though, but that's okay. All right, now how do we find the y values? What we need to do is go ahead and substitute this into x. Now, I'm going to sub it into the line because that is so much easier to do. I'm not going to sub it in twice into here. Again, it's all CAS. So going back to our CAS. All right, so we're going to substitute that into our CAS. So we're going to go to control 8 on 21 times, and instead of having to type this monstrous thing, if you just hover over it, you can actually highlight, press Control C, just like a computer, and then plus a half. All right, and you get this crazy value of y, 882 minus 20 root 43 on 441. All right, and then I'm just going to do the same thing, but with the second one. And to even save me a bit of, actually, don't worry about that. Okay, so we're going to go 821 times, and this time I'm going to scroll over this one and highlight, Control C, straight in, plus a half. Enter. I get, just to keep it consistent, I'm just going to do this. 20 root 43 on 441. All right. What do we think of that? That's pretty crazy, but that is the answer. So, yep, that's how you use your calculator. That's why you need your calculator, because there's no chance that we're doing this by hand. All right, I said last question before. I didn't realize there was another one. So let's have a look. The image below shows the very unhappy bird flying through the air to catch the pig. Very unhappy bird needs to pass through the coordinates 3, 2 and land at the point 22, 2, to catch the pig. So first of all, write down the x coordinate of the turning point. So since we know that it's going to start here and there, the turning point's always going to be in the middle of this flight path. So if this is what it looks like, it's going to be in the middle. So the x coordinate is simply going to be 22 plus 3 divided by 2. So that's 25 on 2. Then it asks for the y-coordinate. Actually, no, it tells us that the y-coordinate is 14. And what it's asking us is to find the value of a in this turning point form here. So we know, if I just write this, and we know that the turning point is at 25 and 2 and 14. So we know that the equation looks like this. X minus 25 on 2 squared plus 14. Now, in order to find a, what we need to do is substitute in a point. And lucky us, we've got 2 points that it needs to go through, 3, 2, and 22 and 2. So whichever one, I prefer smaller numbers. So I'm just going to substitute this in. 3 minus. And again, we are going to our CAS. Do not try this by hand. Okay, CAS time. So solve 2 equals a times. Make sure you put a times in between the brackets. Otherwise, it's not going to know what you're talking about. Squared plus 14, and we're solving for a, so I'm going to go comma a. And I get a is equal to negative 48 on 361. Okay, almost there. We've got hence sketched the graph for the flight of the very unhappy bird on the previous page. I didn't realize that's what I was supposed to do, but sure, I already kind of did it. It's not really to scale though, so let me try that again, because now I know that the turning point is at 12.5 and what do we say, 14 for the, so 12.5, oops, 12.5 would be about there, and 14. So hard to see the scale here. There we go. All right, and it needs to go through these points, so it'll look something like that. Sorry, my iPad, when it, there we go, that's better. All right. Cool. So that's done. And then expand and simplify your answer from part C and hence show that the equation of the flight path of the bird can be written like that, which is pretty disgusting. It is worth 3 marks, so that's telling me that I would have to do quite a bit by hand, but I'm going to definitely be using the calculator to help me make the calculation. So expand by hand. Here's 48 on 361, x minus 25 on 2 squared plus 14. Okay. So the first expansion that I'm going to make is here. So that's a squared minus 2ab plus b squared. That's going to be x squared. And then 2ab, 2 times x times 25 on 2. The 2's will cancel, so that'll be minus 25x. And then plus b squared, so that's 25 on 2. And if you're not too sure, you can do that on the calculator. So 25 squared is 625. On 4 plus 14. Then I'm going to expand the negative 48 on 361x, in, and this is where I'm going to start using the calculator because I don't know how to do this in my head. I'm not expected to. So 48 times 25 divided by 361. I'm just doing this in the background on my calculator, and also it's 2 negatives, so that's going to be 1200 on 361x, and this is really good. I'm very good signs right now. All right, last one, we're doing 48. I'm going to type it as fractions. So 48 on 361 times 625 on 4, enter. And that's going to be a negative. Now, I might actually just do it at, no, I probably shouldn't. So that's negative 7500 on 361, and we just need to add 14. So now we just need to do this last little section, which I'm just going to do on the CAS calculator. On 361x, and so I'm just going to put plus 14. That should be a negative. There we go, and I get negative 2446 on 361, which is exactly what I need. Okay, that is the end of the paper. I know it's quite a long one, but hopefully you've gotten quite a bit out of it. You know, look at the marks, look at whether it's a show that, highlight as much as you possibly can, draw your diagrams, do what you need to do. So that's the worked solutions. Hopefully that helped, and good luck with your SAC.